Hello everyone, welcome to the channel. My name is Sebastian and I'm here with another video how to configure trunks. Okay, and trunks are very important for multiple VLANs, right? If you want multiple VLANs traffic communicating with each other, you need trunk for that to do. Okay, um, because without configuring trunks, even if you have set up VLANs, multiple VLANs, it will be no use. All right, it will be um, you need to configure trunks to able to have all the VLANs work together. Okay, so that's what we're gonna do in this video. And yeah, if you're watching this video and if you don't know how to configure VLANs, stop this video and go to the previous one where I showed you how to configure VLANs. And then once you're done with that, you can come back and watch this video to configure trunks so we can actually ping all the devices in the network. Okay. Um, so all right, so let's start with this one. Um, I'm gonna go here. Let me just pull up my stuff here. Okay, all right. So I'm gonna read out the backgrounds, all right, because the background pretty much tells us, you know, why we need trunks, right? What's the importance of trunks, stuff like that. So trunks are required to pass VLAN information between switches. A port on a switch is either an access port or a trunk port. Access port carry traffic from a specific VLAN assigned to the port. A trunk port by default is a member of all VLANs. So therefore it carries traffic from all VLANs, and this activity focuses on creating trunk ports and assigning them to a native VLAN other than the default. Okay, um, okay, let's do that. And step 1, display the current VLANs. On switch 1, issue the command that will show all VLANs configured. There should be 10 VLANs in total. Notice that all 26 access ports on the switch are assigned to VLAN 1. Okay, let's first open up switch 1. Okay, go to switch 1, hit enter, and let's go hit enable, and then we're gonna run uh, so VLAN brief. Okay, all right, so as you can see here, on the previous video we had configured VLAN 10 as faculty staff, 20 students, 30 guests, 88 management, 99 native, right? So okay, so we have this information. All right, so on switch 2, switch 3, display and verify all the VLANs are configured. So on the switch 1, all the VLANs have been configured. Okay, and then to see that again, let's go to switch number 2, enable, and then so VLAN uh, brief. Okay, so this one. Okay, so switch number 2 have been configured with all the VLANs. That's good. All right, so if I go number 3, switch number 3, um enable, so VLAN brief. Okay, all right, so as you can see, all three switches have been configured with all the VLANs. Okay, um, and all right, so moving to step number 2, verify loss of connectivity between PCs on the same network. Okay, all right, so what I'm gonna do is you can do two ways, right? You can either click this uh, packet right here, click it, and then click PC1, and I know PC1 and then PC4 are on the same network, right? Because 72.17.10, and then they're on the same VLAN. Okay, they're on the same VLAN as well. So if I click PC4, and as you can see progress right here, I'm trying to make it bigger, but it failed. Okay, um, it failed. So it's not pinging. So if I delete this, let's go ahead. Let's ping. Let's run that ping command. So go here, ping 172.17.110.24. All right, let's ping that. Um, give it a minute or a second. Okay, time request timeout. Okay, request timeout. Um, request timeout. Okay. So it's not pinging. Okay. So those, even though they're on the same network and same VLAN, they are not communicating. So this is why we need trunks, VLAN trunks, to enable that communication. All right. Um, so let's go ahead and okay. It says in order to provide connectivity between the PCs on the same network and VLAN, trunks must be configured. Okay, awesome. So let's work on configuring trunks. Okay, step one, configure trunking on switch number one and use VLAN 99 as the native VLAN. Okay, let's go to switch number one. And then we're gonna do this. So move this right here. All right, so you have to be on config term. All right, so okay, it says a configure gig gig O1 and gig O2 interfaces on switch 1 for trunking. Okay, so we're gonna use gig 1 and gig 2 interface for trunking. Okay, and then what we're gonna do is interface range /1 dash 2. Okay, all right, so we are inside that interface 1 to 2, and then we're going to do switch port mode trunk. Okay, all right, nice. Okay, B, configure VLAN 99 as the native VLAN for gig 1 and gig 2 interfaces on switch 1. Okay, all right, let's do that. Switch port trunk. All right, trunk native VLAN 99. Okay, all right. Okay, um the trunk port takes about a short time to become active to spanning tree protocol. So spanning tree protocol is pretty much um, it's a loop. It prevents loop back when you have a redundant path. You need to have this feature to avoid looping, right? To avoid the second link from interfering with the primary link. And click fast forward time to speed the process. It's already active. As you can see, I've got this message. So we don't have to fast forward this. All right, now you configured VLAN 99 as the network as the native VLAN on switch 1. Okay, however, switch 2 and switch 3 are using VLAN 1 as the default native VLAN as indicated by the syslog message. Yes, that is correct, because we have only configured this guy switch 1 as VLAN 99 for native VLAN 99. Okay, okay, so okay, although you have a native VLAN mismatch, pings between PCs on the same VLANs are successful. All right, okay, and then it says explain. That's so um so basically let's do this. All right, let's ping this. I want to put this envelope right here, and then right here, ping. Successful, right? So now they're pinging. Okay, they're pinging, even though we have a native VLAN mismatch, they're pinging, all right? Because the switch is on 99 and those switch 2 and switch 3 are on VLAN 1. Okay. So explain, right? So what I this is what I have, okay? Pings are successful because trunking has been enabled on switch 1, right? Which is dynamic trunking protocol, DTP, has automatically negotiated the other side of the trunk links. Okay, in this case, switch 2, switch 3 have now automatically configured the ports attached to switch 1 as trunking ports. Okay, awesome. So you can write those down. And step 2, verify trunking is enabled on switch 2 and switch 3. Okay, let's verify that. Okay, so on switch 2, switch 3 issue, so interface trunk command to confirm the DTP has been successfully negotiated, trunking with switch 1 on switch 2 and switch 3. The output also displays information about trunk interfaces on switch 2 and switch 3. You will learn more about DTP later in the course. Okay, now let's go ahead and let's see. So on switch 2, let's issue the interface. What's happening? Okay, let me get out of here. I don't want to see all that interface. I'm gonna do so interface trunk. Okay, all right. Oh, I think I'm missing R here. Okay, all right, awesome. So okay, trunking is enabled on switch 2. As you can see, it's on 1 status trunking, right? So it's good. All right, you can run the same command for switch number 3 and you'll see that information. Okay, what I'm gonna do, sorry, so I'm gonna go back here. The questions asked here is which active VLANs are allowed to cross the trunk. So these are the active VLANs that are allowed to, sorry, these are to cross. Okay, 10, 1, 10, 20, 30, 88, 99. So because that one was on our switch number 2, and then I think it's also for switch number 3, it allowed that traffic. So we were able to ping PC4 from PC1. Okay, awesome. All right, so I'm going to move to step 3. What we're going to do is correct the native VLAN mismatch on switch 2 and switch 3. Okay, A, configure VLAN 99 as the native VLAN for the appropriate interfaces on switch 2 and switch 3. Okay, and then issue show interface trunk command to verify the correct native VLAN configuration. Okay, all right. So we're gonna match a VLAN 99 to clear this native VLAN mismatch. Okay, so do that. We want to be on config term, and then you're gonna do interface. We know it's a gig. We can use gig 1 for this. All right, and then we're gonna do switch port mode trunk, switch port trunk native VLAN. That's gonna be 99. Okay, awesome. Now as you can see that consistency restored. All right, awesome. So that's good for this one. Let's go to switch number 3 and do the same thing for this guy. All right, enabled config term. We're gonna do interface. We're gonna use gig 2 for this guy. All right. Switch port mode trunk, and then switch port trunk native VLAN 99. Okay, awesome. All right, so all the switches are on native VLAN 99. Okay, to verify that, let's go ahead and let's do so VLAN brief, right? Okay, there you go, native 99. Okay, so okay, my mouse is not okay. All right, so we can run, let's do actually I'm gonna run so interface gig, this is gig 2, right? We're on this one is gig 2, switch port is on gig 2. All right, oh, I think that's a oh, like that. TCS port. Okay, now okay, so things to look here would be administrative mode is trunk, that's good. And then you want to look trunking native mode VLAN 99 active, that's awesome. And you can run the same so command to see on the switch 2, and you'll see that. Okay, and then okay, we're on step of verify configuration on switch 2 and switch 3. We already did that. Issue so interface port command to verify the native VLAN is on 99. Use the VLAN command to display information regarding configuration VLANs. We already did that. Why is port gig 1 and on switch 2 no longer assigned to VLAN 1? Port, yeah, gig is a trunk port, and trunks port are not displayed. Okay, so that would be the answer to that question. All right, and that's it. We're at completion 100%. So that's how you configure trunks to allow multiple VLANs to communicate, and then this will the trunk will carry all multiple VLANs traffic, and then they can communicate, they can work with each other. Okay, so this is it for today's video. Keep watching, I've got fun stuff coming up, and you have a great day. I will see you in the next video. Bye bye.